AI finds the bugs now. GitHub's RCE and the new offense defense calculus. Wiz Research just published the technical breakdown of CVE20263854, a critical remote code execution vulnerability in GitHub's internal Git infrastructure that any authenticated user could trigger with a single Git push. The exploitation chain is elegant in its simplicity. GitHub's internal Babeled proxy copies Git push option values directly into an exstat header without sanitizing semicolons. Since semicolons delimit fields in that header, an attacker can inject arbitrary key value pairs, including Rails inv, custom hookster, and repo pre-receive hooks, to bypass sandbox execution, redirect hook script lookup, and achieve path traversal to any binary on the file system. The result, unsandboxed code execution as the Git service user, with file system access to every repository on the affected storage node. On GitHub.com, Wiz confirmed that millions of public and private repository entries belonging to other users and organizations were accessible from compromised nodes. The most consequential detail isn't the vulnerability itself. It's how it was found. Wiz credits AI-augmented reverse engineering, specifically IDA MCP model context protocol integration for the IDA disassembler, with making the discovery feasible. In prior rounds of research, extracting and auditing GitHub Enterprise servers' compiled binaries was too costly in manual effort. This time, AI reconstructed internal protocols, traced user input flow across multiple services written in different languages, and identified where assumptions diverged. GitHub mitigated the issue on GitHub.com within 6 hours of the initial report, but at disclosure time, 88% of GS instances remained unpatched. That gap between cloud and self-hosted patching speed is worth watching. It's the same pattern that makes enterprise software a persistent target. The vulnerability also surfaces a pattern that extends well beyond GitHub. When multiple services pass data through a shared internal protocol, each service's assumptions about that data become an attack surface. One service assumed push option values were safe. Another assumed every exstat field came from a trusted source. A pre-receive hook assumed a certain environment variable could only be production in production. Each assumption was individually reasonable and collectively dangerous. Meanwhile, a U.S. government memo on adversarial distillation is raising questions about whether open-weight models need tighter export controls. The concern being that state actors can distill capabilities from frontier models into smaller, ungoverned ones. Whether the policy response lands on controls or capacity building will shape the open-source AI ecosystem for years. On the fraud side, a research repository called GPPPP Team documents the full attack chain for replaying ChatGPT Team subscriptions, from Stripe checkout through PayPal billing agreements to Codex OAuth token extraction, complete with a 4000-line HCAPTCHA visual solver and empirical anti-fraud data. The research findings are more instructive than the tooling. Batch-created accounts show a next-day survival rate of approximately 2%, killed by IP-level string fingerprinting, batch correlation with delayed bans, and a clear separation between probe layers that detect and ban layers that act. It's a useful case study in how modern anti-fraud systems use layered, delayed enforcement rather than real-time blocking. Structured prompts, shared protocols, and the governor problem. Martin Fowler's Thoughtworks just published what may be the most rigorous treatment yet of how teams should actually use AI coding assistants at scale. Their method, Structured Prompt-Driven Development SPDD, treats prompts as first-class delivery artifacts, version-controlled, reviewed, reusable, and governed by the same discipline as code. The core structure is the Reasons canvas, 7 dimensions spanning requirements, entities, approach, structure, operations, norms, and safeguards. The canvas captures intent, domain model, design decisions, constraints, and task decomposition in a single artifact that the LLM operates within. The workflow enforces a critical rule. When reality diverges, fix the prompt first, then update the code. Refactoring flows the other direction. Change the code, then sync back to the prompt via /speedasync. The result is a closed loop where prompts and code evolve together rather than drifting apart. The 3 skills SPDD identifies: alignment design before you generate, abstraction first lock intent before you write code, and iterative review turn output into a controlled loop, are exactly the skills that separate developers who get consistent value from AI assistants from those who get fast garbage. The fitness table is refreshingly honest. SPDD rates itself 5 stars for scaled standardized delivery and high compliance environments, but only 1 or 2 stars for firefighting hotfixes, exploratory spikes, and one-off scripts. This is engineering discipline applied to a new tool, not a silver bullet. The walkthrough of enhancing a billing engine demonstrates the full cycle from requirements through analysis, canvas generation, code generation, verification, and regression testing. A complete end-to-end example that teams can actually follow. A complementary approach emerges from a blog post about running 2 Claude code sessions against 1 repository. Rather than a formal framework, the author discovered that when context runs out in a brainstorming session, you can spin up a second agent for the editing work and coordinate them through a shared Markdown protocol file. The primitives are minimal: roles drafter/editor, turf directory-based boundaries, named handoff units, 1 Markdown file per atomic edit, and a human message bus. Neither agent can self-approve. The drafter proposes, the operator approves, the editor applies. The protocol grew organically as the agents themselves identified gaps. The editor proposed a visual layout verification rule when it realized it couldn't validate rendering changes. The drafter proposed stricter source document drift detection. Sentrux attacks a related problem from the measurement side. It's a Rust-based architectural sensor that watches code bases in real time, computing 5 root cause metrics: modularity, acyclicity, depth, equality, redundancy into a single continuous score. The thesis is sharp. The better the AI generates code, the faster your codebase becomes ungovernable. Every AI session silently degrades architecture. Scattered responsibilities, tangled dependencies, conflicting abstractions. And without structural feedback, the next session makes the mess worse. Sentrux integrates as an MCP server so agents get real-time access to structural health. The quality gate catches regression. Save a baseline before an agent session, compare after, block degradation. 52 languages via tree sitter, single binary, no runtime dependencies. Rounding out the tooling theme, gopher-code is a ground-up rewrite of Claude code from TypeScript to Go. 513,000 lines of TypeScript distilled into idiomatic Go with a 12 ms cold start, single static binary, and 33 built-in tools. It's currently at roughly 3% parity across 594 identified tasks, so this is early stage, but the architectural choices are interesting. Bubble T for the TUI, context-first cancellation on every goroutine, interfaces at all boundaries, and golden file tests against captured Claude code transcripts for behavioral parity validation. A workshop video by Cole Medin demonstrates a 3-phase AI coding workflow. Strategic planning, a plan, implement, verify loop, and system evolution that maps naturally onto the structured approaches described above. The model race. Qwen ties Sonnet, GPT-6 surfaces, and Google bets $40 billion. Qwen 3.6 at the 27 billion parameter size is posting agency benchmarks on artificial analysis that tie with Claude Sonnet 4.6. A remarkable result for an open-weight model running locally. The 27B parameter count hits a sweet spot. Large enough for complex agentic tasks, small enough to run on consumer hardware with quantization. For the agentic coding use cases dominating today's developer workflows, agency benchmarks matter more than raw text generation quality. A model that reliably plans, uses tools, and self-corrects is more valuable than one that writes prettier prose but stumbles on multi-step reasoning. Qwen 3.6 closing the gap with a frontier commercial model at a fraction of the parameter count signals that the open-weight ecosystem is maturing faster than many expected. This arrives alongside the first direct side-by-side comparison of mixture of experts versus dense architectures at equivalent compute budgets, a test the community has been requesting for years. The results should inform architecture decisions for anyone training or fine-tuning models. Whether the MOE routing overhead pays for itself in quality per flop depends heavily on the task distribution and inference hardware constraints. On the frontier model side, OpenAI has confirmed GPT-6 is in development. No timeline, no architecture details, just acknowledgement that the next generation is underway. Meanwhile, Google is reportedly investing up to $40 billion in Anthropic, spreading its AI bets beyond its own Gemini line. That investment, if confirmed at scale, would make Anthropic one of the best capitalized AI labs and raises questions about competitive dynamics. Google funding a direct competitor to its own flagship models is a hedge that suggests even Google isn't sure which architecture or approach will dominate. For Anthropic, this kind of capital runway could fund the safety research and scaling experiments that differentiate its approach. NVIDIA's Nematron Nano 3 Omni is gaining Llama.c P support through a conversion PR, adding another multimodal option to the local inference stack. The Omni designation signals vision, audio, and text capabilities in a compact form factor designed for edge deployment. Local inference gets serious, KV cache persistence, Blackwell FP4, and quality beyond TPS. The persistent complaint about local LLM inference for agentic coding is that KV cache invalidation kills latency. Every time an agent circles back to a previous prefix, which happens dozens of times per session, the entire cache is recomputed. OMLX tackles this directly by persisting every KV cache block to SSD on Apple Silicon, restoring from disk in milliseconds instead of recomputing from scratch. Benchmarks on an M3 Ultra 5, 12 GB show QWEN3.5 models hitting 941 tokens/second prompt processing at 8K context, with 8 request continuous batching pushing throughput to 190 TOC/s, a 3.36x speedup over single requests. The 405B parameter class manages 16.7 TOC/s single request, scaling to 60.3 TOC/s at 8x batch. The pitch is that this makes local inference fast enough for coding agents that need responsive tool calling loops. Llama.c p build B8967 introduces native NVFP4 support for NVIDIA's Blackwell architecture, meaning the B100/B200 GPUs can now run 4-bit quantized models through Llama.cp's inference stack without workarounds. This is significant for anyone deploying local or on-premise inference at scale. Blackwell's native FP4 throughput is substantially higher than emulated quantization on older architectures. A project called Sigilant shifts the local model selection conversation from raw tokens per second to tool calling pass rate as the primary quality metric for GGUF quantizations. The argument: TPS tells you how fast a model talks, but not whether it can reliably call tools. And for agentic use cases, a model that's 20% slower but 40% more reliable on structured tool calls is unambiguously better. This is the kind of practical benchmarking the local LLM community needs more of. Meanwhile, a frustrated r/local LLMA post titled "I'm done with using local LLMs for coding" captures the other side of the experience gap. When local models fail at complex multi-file edits that cloud models handle reliably, the cost savings aren't worth the context switching overhead. Research. Smarter LoRa Merging and Agentic Knowledge Traversal. A new paper from KAOST introduces TARAM, Urging Task Rank Anisotropy Alignment, a framework for combining multiple LoRa adapters into a single model that addresses 2 properties most prior methods overlook: subspace coverage and directional anisotropy. The problem is practical. When you've fine-tuned separate LoRa adapters for different tasks and want to merge them into one general-purpose model, naive combination erodes the representational directions most critical to certain tasks while overemphasizing others. Tara decomposes LoRa updates into rank 1 directions, measures how broadly those directions span the parameter space-subspace coverage via effective rank, and quantifies how unevenly task losses respond to different directions anisotropy via the task loss Jacobian singular value spectrum. The method offers 2 variants. Variant A reweights individual rank 1 factors within each adapter, and Variant B constructs a shared orthonormal basis across all tasks via SVD before assigning per-direction weights. Variant B consistently achieves the highest scores: 76.3% average normalized accuracy across 8 vision benchmarks with CLIP VI-D/3, 2 and 80.3% on 6 NLI benchmarks with LLMA38B, outperforming both vanilla baseline's task arithmetic, TEAS, DARE, AdaMerging, and LoRa-aware methods no TS, LAR, ALEGO robust merge. The generalization results are particularly interesting. Models merged on 6 seen tasks and evaluated on 2 unseen tasks show Terra achieving 7.0.9. 7.2. 1% overall accuracy versus 6.6. 4. 6.6. 7% for the next best method. For anyone building multi-capability systems by composing task-specific adapters, this is a meaningful step toward principled merging that respects the geometry of what each adapter learned. On the retrieval side, Stuart Wintertier's analysis of autonomous knowledge graph exploration reframes the problem in a way that resonates with production RAG systems. The insight: knowledge graphs aren't the autonomous part. The agentic retrieval process sitting on top of them is. Retrieval becomes an adaptive control problem where the system needs to follow relationships, use relational context, traverse structured evidence, and know when to stop exploring. The failure mode isn't just missing the right answer. Sometimes the system never leaves the surface, and sometimes it drifts endlessly. For enterprise applications where agents need reliable paths through structured organizational memory, this framing of retrieval as control is more useful than another round of semantic search benchmarks. Agentic worlds, multiplayer AI games, and decentralized compute grids. Pipecat's Gradient Bang is an open-source multiplayer space game where every entity, including the ship you command, is an AI agent. It's built on Pipecat for real-time voice, Supabase for the game server, PostgreSQL with Edge functions, and React for the client. The technical architecture demonstrates full-stack agentic workflows, multitasking across exploration, trading, and combat, tool calling for game mechanics. low latency voice interaction with DeepGram STT, Cartesia TTS, and Gemini or Claude for reasoning. The bot process supports both voice agents' real-time conversation and NPC task agents' autonomous missions. A local pooler mode bypasses Supabase edge function network hops for co-located deployments, cutting latency from 500 ms average to near zero. The project is also a showcase for Claude code integration. /init sets up the entire stack, /deploy handles production deployment, and /npc launches autonomous agents as named characters. Agent FM takes a different approach to agent infrastructure. A peer-to-peer compute grid built on lib2p that turns idle hardware into a decentralized AI supercomputer. The pitch is SETI at home, but for AI. Workers run agents in Podman container sandboxes. A boss node orchestrates and dispatches via an OpenAI-compatible API on standard endpoints /v1. /chat /completion /v1. /models. Relay nodes handle NAT traversal. Hardware-aware routing broadcasts live CPU/GPU/Q state every 2 seconds, and the matcher picks the least loaded peer per request. End-to-end encrypted streams via lib2p noise, PSK mode for fully isolated private meshes, and bearer token auth with constant time comparison. It's a single statically linked Go binary for Linux, macOS, Windows, FreeBSD across 6 architectures. Microsoft's Trellis.2, a 4 billion parameter open source image to 3D model with PBR physically based rendering textures, extends the generative AI toolkit into spatial computing. Useful for game development pipelines and digital twin creation where 3D asset production is the bottleneck.